Hi, and welcome to the latest IoT Now Quickfire interview, in which we're talking about scaling up security with eSIM. And I'm delighted to have here Marco Bijvelds, who is Senior Vice President for Europe and Asia Pacific at Core Wireless. Marco, good to have you here.
Thanks for having me, Jeremy. Appreciate it.
Marco, organizations have traditionally relied on cellular connectivity that's delivered via SIM, subscriber identity module, and for their IoT deployments. But there are some issues with that approach for organizations. Can you explain what the problem is and why they're looking at eSIM?
Yeah, so I think fundamentally there are two problems with traditional SIM cards, which have to do with also the IoT adoption that is impeded by those factors. So first of all, I think security has been one of the issues for the adoption of IoT in general, and also for the adoption of connectivity solutions with many customers that we see. So that's one factor that is playing into that. Secondly, we noticed that there's no single solution out there that has that quality of service, that footprint, that's providing customers with a single solution that they can IoT deployments, which fundamentally increases their cost for their IoT deployments and risks their investments on their IoT. So those two factors lead customers towards eSIM, and eSIM is actually addressing those two issues in different ways, which I will elaborate on probably later.
Okay, so what exactly are the key drivers and the primary use cases for eSIM, and are there any foreseeable challenges with security there?
Yeah, so let's look into the three main use cases that we see for eSIM. Fundamentally, those are the main drivers for eSIM in the marketplace. So first of all, to my earlier point, connectivity, ubiquitous connectivity is crucial to make sure that we have a solution that is cost effective. So a normal SIM card just provides a single carrier connectivity, which is limited by definition. eSIM, with the ability to download profiles, obviously has that flexibility to download other carriers where that's needed. And in some cases, you cannot work with a roaming solution. You have to have local connectivity because of restrictions, legislations, policies, maybe even latency issues that require to use local profiles. So that's one big reason. The other reason is around future proofing. Think about many of the IoT devices go into the field for many years. Well, I think one of the known examples is a smart meter that is in the field for 15, even 20 years. And in that 20 years, the external factors are changing. We've been facing already some 2G sunsets, which have caused customers to swap their devices, which is extremely expensive. So eSIM would allow to future-proof those devices and coping with those unknown external factors. A third element of eSIM, or a third use case that we distinguish, is reducing the complexity in manufacturing devices. So this is very much tied into OEMs that are manufacturing devices on a single location and they have to deploy globally. They don't know where the device is going to end up, so they don't know which connectivity they have to provision on their devices. And eSIM, with the ability to download that profile once it's deployed in the field and has this local connectivity enabled, solves that complexity in the logistical chain and in the manufacturing process as well, which in its turn reduces costs, reduces operational burden, and therefore facilitates the adoption for IoT with our customers. So those are the three main use cases that we see. A fourth one that we see as well, which is related to the security aspect that you alluded to, is the fact that because the eSIM allows for downloading of profile, soldering a SIM card on a PCB on a device does no longer mean that you have to change the whole device if you change the carrier. So embedding a SIM card on a device means enhanced security levels because you cannot take it out of the SIM card, so there's less risk to fraud of the SIM card. So those four elements we do see as the main drivers for eSIM.
So could you walk us briefly through a typical eSIM connectivity infrastructure and give us an idea of where organizations should be thinking their levels of security fit in?
Right. So the architecture obviously consists of an eSIM, which is called EUICC in the eSIM world. That's the physical piece, the physical element that contains the eSIM profile. So that's a must-have in the eSIM ecosystem, as well as the RSP, the remote SIM provisioning platform. So those two allow for remote SIM provisioning over the air. But we do see that as the plumbing, right? So those are the necessary elements to do some switching, but it's not sufficient to actually use eSIM capabilities in a smart way. So our ecosystem, Core's ecosystem, consists of a number of elements on top of that, including the core network. So where the eSIM profile management is being done by the RSP platform, the core network allows us to build our own eSIM profile and provide a very strong bootstrap that can be used globally, and also provides us with full control and flexibility over that connectivity as we control the core network. So those two elements are fundamentally the backbone of our solution. And on top of that, I think that's important to mention, the connectivity management platform, Connectivity Pro, that we're using is actually orchestrating all those use cases. The fact that you can switch doesn't mean that you automatically switch at the right time. So doing the orchestration of the eSIM profile management, the switching, the downloading, everything related to that is done through our connectivity management platform. Maybe last thing to highlight, I think something that is missed or not considered by many people is the fact that eSIM allows us to increase the security levels through new applications on the eSIM, like cloud to device authentication and like data encryption on the SIM card itself. Those are new use cases that weren't possible before and are enabled by eSIM. So those elements to us are crucial when you consider an eSIM architecture.
The GSMA's security accreditation scheme is trying to help with a standard approach to certification for physical SIM and RSP. How do you think this impacts eSIM adoption by the market?